Hello all, welcome. Welcome to ENU308. How many of us over here are actively working on migrations? And how many of us are at some stage of enterprise modernization? All right, do we have anybody from the energy industry who's working with energy or commodity trading or trading in general? All right, well, that's excellent. Well, this session is for all of y'all and others as well. We are going to talk about BP Trading's digital transformation on AWS and how they went from migrating legacy applications to AWS, modernizing their infrastructure in AWS, and now how they are innovating with AWS. My name is Amruta Karnik. I am a senior solutions architect with AWS, working primarily with energy customers like BP. And today, I am very excited to be co-presenting this session with Tara Warner, VP of Digital Supply Trading and Shipping. Tara?
Thank you.
All right. Yep. So as a part of this session, we will be discussing how enterprises think about their overall digital transformation with cloud adoption. And then Tara is going to do a deep dive of some real-world examples, and we are going to learn how BP was able to solve complex challenges, optimize processes, and build innovative solutions, unlocking opportunities by building in AWS. And now that being said, I invite Tara to tell us the BP story.
Thank you. Good morning, everyone. As Amruta mentioned, I am Tara Warner. I look after our supply, trading, and midstream portfolio of applications at BP. It's a complex portfolio of about 600 applications, and I have a team of just over 1,000 people working worldwide. For those of you who don't know much about BP, we are one of the most advanced commodity trading houses in the world, actually. We have around 2,000 people in 40 offices across the globe. We have 4 trading hubs. So we've got Houston, London, Chicago, Singapore, and we serve about 12,000 customers. Just to put it in perspective, we trade about 4 billion barrels of crude each year, and we move around 14 BCF of natural gas over 235 pipelines. So big, large, complex business with a whole set of systems that underpin it. The slide that you see behind me actually is our Houston trade floor, which incidentally is where I am based currently as well. And so we're going to talk a little bit today about just our migration into the cloud, so how we've migrated, shifted to optimizing, looked at modernizing some of our applications, and now are really working in partnership with AWS to innovate around those trading applications. So our cloud journey really started back in 2016 when we made the decision, an enterprise decision, to exit our data centers. So we started actually in the Americas a little bit sooner, and we've been operating our entire digital estate in the cloud since about 2023. For trading, with a few exceptions, that's almost entirely in AWS. Our cloud journey really, our first move was just to lift and shift. So we wanted to get our applications out of our on-prem data centers, get them into the cloud, and build up the capability that we needed internally to be able to operate that in the cloud. And so, we've got a few years behind us now. And again, as I mentioned, we are now looking to really, how do we make the most of it? How do we optimize further? And how do we modernize? So a few things that we have done. So, we were fully, I think, up and running in the cloud by 2023. We've got a big ETRM, or an energy trading risk management system, that I'll talk about a little bit later, that we moved back in 2019. And then we've really been settled and working on optimizing all of those applications further, and then really starting to leverage the native architectures in AWS by building out some of our own applications, and we'll talk about that a bit later as well. So I saw earlier, several of you raised your hand that you're involved in some sort of commodity trading operation. If you are, you know that the whole trading business runs basically on data and systems. So we've got heavy reliance on availability, reliability, and security. So how has the cloud helped with any of those things? I'll focus on just a few key benefits that we're seeing at BP, and it's not an exhaustive list. There's a lot of things that have improved with our move to the cloud, but one of them is delivery speed. So we used to, in our on-prem data centers, write a document called a TIP, a technical infrastructure plan, every time we wanted to scale out our infrastructure, put new servers in. It would go through various levels of approval. We would have to figure out, did we have to amp up cooling? Did we have the rack space? Did we need to expand? And that process would literally take months, sometimes years. By the time we procured the hardware, staged it, installed it, you were looking at maybe a year before you had the infrastructure that you needed to start building out new solutions. With the move to the cloud, we can do that almost instantaneously. So, if we want to spin up environments to do a quick POC, to test out new products, to, model new instruments, we can do that, in the blink of an eye, really. And so the time to market and just the delivery that we can do for the business has improved significantly in the cloud. The other thing that's really important in a trading operation, and for those of you that work in trading, you'll know this, is resiliency. So we used to, have on-prem data centers. One of them was in North Houston, and the other was, our backup site was Chicago. Is there anyone in the audience also from Houston? So if you are, you'll be familiar with the 6 months of the year that we call hurricane season. For us, I can actively remember at least 4 instances where we went into some real disaster recovery or business continuity scenario. So hurricanes, I want to say Rita, Harvey, Ike, and Winter Storm Uri. What used to happen when we were still on-prem is that it would take us days basically to fail over literally hundreds of components from our North Houston data center that was in a hurricane corridor and into Chicago. You often couldn't find people. It was hard to track people down. It was a very complex orchestration of taking things, down in one data center, bringing them back up. The DR exercises that we do and have to do actually as a regulated entity each year have gone from taking entire weekends to a matter of hours, just because we can seamlessly fail over availability zones that quickly. And I think the other good thing or the other advantage for us is that none of the availability zones that we operate in are in hurricane corridors. So that's quite a relief as well. Thank you, AWS Ohio. So that's another big benefit that we've seen. I think the other big thing is cost savings. So we are able to optimize costs. We never had the ability to spin environments down or up when we needed them just for quick things. We had no burst capacity to scale up for compute intense processes that we run, like our end of day scenario. And so we've, now that we've got a few years behind us, we've really, I think, gotten that down to a science. We've got a lot more visibility and a lot more transparency into our costs and the ability to manage them more agilely. So we are seeing good cost savings. On the cost savings front, the other thing that we see is we used to refresh our infrastructure probably every 3 to 5 years. By the time we actually procured the infrastructure, got it in, we never had, access to the best class of machines or instance types. So through this, we really are in an evergreen portfolio. That matters tremendously because the speed of accessing data in trading is really what matters. And so having the ability to just, have the best-in-class machines at our fingertips has been game-changing for us as well. So I'm going to flip over and talk a little bit about some of the applications that we have moved and some of the things that we have built now that we are in AWS. And I'll start with something that I've worked with very closely, actually, throughout my entire career. And I should have started with, actually, so I've been at BP for almost 22 years. I started at BP in 2003. And actually have worked my whole career in energy trading systems, trading models. So I've had the opportunity to sort of witness this evolution firsthand. And I can say, actually, I've spent a lot of my career working with ETRMs, or energy trading risk management systems. And if that's a term that's unfamiliar to you, an energy trading risk management system is really the core of how we manage transactions for trading. So it's everything from pre-deal analytics, should I do this trade, to deal capture, to valuation, position management, through to sort of settling trades when cash comes in the door. We do have a big physical business at BP, so there's a lot of complex logistics involved. How do I get my commodity from point A to point D, and then optimizing across all of that through the deal life cycle. We use the ETRM data sets to run regulatory reports. We run our credit and market risk on the ETRM data. And so it really is, a critical trading application for us. We use Ender, an ION product, for one of our core ETRMs, and we use that for gas, power, and LNG globally. And so that's the example that I'll talk through today, because that was one of the biggest applications that we moved over in our cloud journey. So just to give you sort of a frame of reference of the scale, we have about 700 users in Ender today. We have 431 servers, 60 instances, and we run multiple computationally intense sort of valuation processes through the system. It processes millions of transactions every year, and we have 3 instances of Ender. So very large installation of Ender. So again, our initial focus was really just lifting and shifting. How do we get this thing out of the on-prem data center that we had up into the cloud? People will argue with me on this, but I think we were the first, maybe one of the first customers to actually move Ender into AWS. And so we encountered several challenges along the way. We had problems with spread messaging, unicast and multicast that we worked through with ION and AWS. And so with a lot of coaching, guidance, help, we finally got it up and ready in the cloud. And then since then, we've really focused on optimizing how do we actually leverage some of the elasticity, the burst capacity, how do we tune for better performance, how do we really optimize this to run efficiently in the cloud. And then the next thing that we've really looked at is how do we potentially modernize and displace some of the features that aren't working that well for us. One of those is position management. So position management is really key to trading. That's really, what helps traders make decisions around what volumes do I have where, how much exposure do I have, how much risk do I have. It's a good tool for the traders to communicate with operators so that they can figure out, where do we have volumes, where do they need to move to, where do we have storage, how much risk do we have around any of this. So having real-time positions is very important. The solution that we have today, it has some challenges. It's costly, it's non-performant. It takes a long time to recover if there's any errors. So there's quite a lot of upstream processes that run to get to the point where you've got positions. And when you don't get that sort of start of day position right, very hard to recover from, and it's very time consuming, and that's time that we're out of the market in trading, and so that you definitely don't want to see that. So faced with all those challenges, we partnered with AWS to try to build out our own position manager. One of the other drawbacks of the solution that we have now is that it's very tightly coupled to the Ender application. It can't ingest data from multiple sources, so we don't have a lot of flexibility. It's not very extensible. You can't customize it very well, and there's no real visualizations. And so we really set out with AWS to look at how do we build something better. So happy to say we actually have a pretty good prototype that we have ready. It's using MSK for Kafka streaming from Ender into Aurora, using QuickSight for visualizations, and it looks really promising. And so I will turn over to Amrita to talk a little bit more about the detailed architecture that we're leveraging there.
Awesome. Thank you, Tara. So considering the challenges that Tara just outlined in the previous slide, BP decided to explore some options for the existing position management solution. And one of them was augmenting the existing functionality with cloud-native architecture. So what you see here on the screen is still the data flowing through the existing ETRM system in order to get it ready for the position manager. So we have two ways in which the data flows. One is the start of the day data set. So this is the nightly batch processing that takes place, applying some price adjustments and such, and getting the data ready for the next business day. The second is the real-time changes that pass through the application. So this is the regular business day process that happens once the trading starts. So in terms of scale, we are going to be working with about 70 million records that need to be processed as a part of the batch process. And we're going to be working with 1,000 records that are generated per minute when we have start of regular business day. Tara? All right. OK, so let's walk through the building blocks of the architecture. So the data from the calculation engine, which is the data about the positions, that needs to be landed on a stream. Then we need to have a data store or a database where we are going to store this data, apply transformations, and then make it available for a visualization application or a visualization tool. So keeping the SLAs, the data, the volume of data, and the functionality in mind, we decided to explore the architecture that Tara alluded to us earlier. And then in terms of the actual SLAs that we are looking at, we need the data to be visible on the visualization application within under a minute after the data has landed on the stream. And then in terms of functionality, what we were looking at that time was an ability to join data sets real time, to enrich data with additional contextual information. And we also wanted to apply access control mechanisms based on row as well as column level filtering. And then we wanted it to limit certain dashboards and certain visuals for certain users or user groups. So considering all these requirements, this is the AWS native architecture that we proposed. So for the streaming service, we are using Amazon MSK. We have MSK deployed in multiple availability zones because it is a critical business application. We have AWS Lambda, which has MSK as the event source, and it processes the messages, transforms them, and further does upserts or inserts into the Amazon Aurora database. For the visualization application, we are choosing Amazon QuickSight. Now, Amazon QuickSight has a direct query option with which you can directly connect to the respective data sources or data stores when we have use cases where we have strict SLAs like this one. Plus, QuickSight also offers an administration interface, so where we have admins or writers, as we call them in QuickSight terminology. They can come in, join different data sets, and create new visuals. Plus, QuickSight also offers the access control mechanisms, so that you can have your users, user groups, get access to certain visuals, certain dashboards, and you can also have the row and column level filtering applied there. Plus, since this is numerical tabular data, BP wanted this to be represented as pivot tables with drill down capabilities, so that you can click on a cell and then the rows that made up the data in the cell are visible. So pivot table is something that QuickSight was able to support with the drill down capability, hence QuickSight was chosen as the tool. Now, this option was about 1/3 of the cost of the other solutions that BP was considering. Hence, BP decided to further go ahead with this prototype. And now that being said, I hand it over to Tara.
Right, so that was a great example of actually how we're able to build something out that will eventually help us save license costs, perform better, and it's just more feature rich and will work better for our business. Another example that we have of where we've modernized and started to re-architect applications is with our market risk application. So for those of you who are in trading, you probably know about value at risk. Value at risk is a pretty computationally intensive process that figures out the maximum potential loss that you might have in your portfolio due to price fluctuations or things in the market. In simple terms, it really tells you how much you could lose, the probability that you will lose that much, and over what time horizon might that loss occur. So really important for trading. It allows us to sort of protect our profits and manage risk across the portfolio. It's massively data intensive. It may sound simple, but it's actually a complex series of Monte Carlo simulations that spit out all of this data that model things like price fluctuations, geopolitical disruption, weather events, things that might happen. So we stress and load test that and really try to actively, proactively manage and mitigate any risks that we have in the portfolio. So we had a solution that, again, wasn't performing all that well. It was built in somewhat dated technology and really didn't allow us to do anything intraday. It was very slow. We couldn't do a lot of what-if scenario analysis in it. So we once again partnered with AWS to figure out if we could come up with a better solution. Just to sort of highlight the scale and the amount of data that gets processed in a value at risk calculation, I'll rattle off a few stats. You can see them behind me here, but we've got 250 million price predictions that it goes through. It generates a 25,000 by 25,000 correlation matrix to do the calculations and just crunches through a whole lot of data. So, when we set out, I guess, to solve that problem, we had to keep all of those things in mind. Up until recently, we were using a risk engine that was built on Apache Ignite and MATLAB, and just, we figured there had to be a better solution. And so I will hand it over actually to Amrita to talk a little bit about the architecture that we came up with to solve that problem.
All right, thank you, Tara. Okay, so what we see here is the data flow diagram. We have source systems, and those source systems have data about prices and the different commodities that BP trades in. This data is extracted, transformed, and loaded into a historical data store. Market risk engine applies Monte Carlo simulations on this data store and generates VAR or value at risk and other reports. So as Tara mentioned, this engine was previously written using MATLAB and Apache Ignite. So the way in which the architecture was structured, it was unable to scale. It always had to be provisioned for peak, and even then, the engine would crash and calculations would fail during volatile business markets, especially since BP trades across multiple markets. End of day for one is the beginning of the day for another. Thus, some of the larger commodities would take a very long time to process. Hence, BP decided to redesign this engine. All right. Okay, so let's build out the architecture. So what we have over here is the market risk engine services. So these are the ETL processes. So these are going to gather data from different commodities, and that's going to be inserted into an Amazon RDS Postgres database. And for the file-based data sets, we are using S3 as the data store. All right, so next, let's take a look at how we are going to orchestrate the calculation requests to the calculation engine. So considering we are working with multiple markets and multiple commodities, once the data is going to be ready for several commodities, it needs to be queued and it needs to be distributed. So for that, once the data is ready for a particular commodity, a message is placed on an Amazon SQS queue. We have an engine orchestrator, which is deployed on Amazon ECS, which is the Elastic Container Service. That is going to pull the Amazon SQS queue and pick up the messages and then process it. This engine orchestrator also acts as an entry point into the engine and adds additional security layer because now the access to the engine is only available by the orchestrator. So majority of the jobs that are processed by this engine are all large jobs, and hence the processing is done in this asynchronous manner where a message is placed on an Amazon SQS queue. But there are some smaller jobs, and those are handled using REST APIs. Okay, all right, so now let's take a look at the actual calculation engine. The calculation engine, which runs the Monte Carlo simulations, is built using EMR serverless. So EMR serverless automatically calculates the resources that the engine is going to need, provisions those resources, and then releases those resources once the job has finished execution. So for the jobs that need a response in seconds, like for instance, interactive data analysis for ad hoc calculations, in that case, EMR serverless supports having a pre-initialized capacity. So for those jobs, a message is placed on an Amazon SQS queue which has an identifier for the pre-initialized capacity. The orchestrator further has rules that set the number of executors, the memory execution, and a warm pool of workers is created when this EMR serverless application is created. Okay, so next, let's take a look at the ingest, process, and publish piece. This application also uses YAML config files for defining the job configuration. So the configuration file has information about the connectors, the data sources, the file format, and the order in which the data needs to be processed in case we have multiple data sets. This data is processed, converted into a Parquet file, and stored in an S3 bucket. The process piece is where the Monte Carlo simulations takes place, and this is the piece that historically would fail because it was unable to scale on load. So the process piece applies the Monte Carlo simulations on this data. The results are stored in an Amazon RDS Postgres database, and reports are written to an S3 bucket. So this is a very modular, decoupled application, and hence, after the framework was built, BP was easily able to add new use cases and onboard new commodities on this architecture. Plus, since this was a redesign of an existing application, a major factor that was going to determine the success of this was going to be the amount of time and the effort that this application was going to take to redesign. So the BP teams were able to use majority of the code that they previously had for the orchestrator, and they were able to use 80% of the queries with EMR serverless as well as the stored procedures. And now with that, I pass it back to Tara to take us through some of the modernization benefits.
So I think in the simplest terms, it's saving us 100% of the license costs that we were paying to a third party. We are saving 35% on our compute costs with the new architecture. And we're really able to onboard new use cases much quicker. We're seeing a 40% performance improvement over our previous tools. And that's allowing us to run simulations intraday in parallel with other things that are happening in the portfolio. And so just generally, I mean, it's a better, more performant solution than we had previously and lower cost. So we've migrated, we've optimized, we've re-architected some of our applications. No technology talk, I think, would be, appropriate in this day and age without touching on AI. So let's talk now about an example where we are using AWS native architectures, leveraging AI in our business. I'm going to switch gears a little bit and talk about the supply side of supply trading and shipping, which is really our fuel supply and midstream business, and use an example, our global integrated pricing program that is really looking at how we price fuel for our retail sites. Historically, the systems that we've used for this are third party. They're quite dated. They're hard to customize, they're hard to configure and manage, and we've had little pockets of fragmented solutions across the globe. So we really set out to build a more harmonized process, simplify this, make it more efficient, and get on a unified platform across the globe so that we could offer better competitive pricing to our end-use customers. So again, we teamed up with Amazon to look at how might we build our own pricing platform and solution for our retail sites. So just as a side note, actually, you may have seen, and this isn't an infomercial, by the way, this isn't a shameless plug, there is a connection back to what I am talking about, but you may have seen recently that BP actually announced a partnership with Amazon. So if you're an Amazon Prime customer, you can get 10 cents off per gallon if you use our Earnify app at our retail sites. So the connection back to this is really that at some point you will be seeing the price that you see at the pump is based on sort of augmented intelligence, where we're looking at competitor data, we're looking at market data, and coming up with the best price that we can offer at the pump. It's a phased program, and we have not yet rolled it out in the US, so you won't see that quite yet, but it is in use in about 4,300 of our retail sites today.
All right, okay.
Yeah, and actually, so I will turn it over actually to Amrita to talk a little bit about the tools that we're leveraging and the AI aspects of that.
Excellent, awesome. Thank you, Tara. So now we clearly know that the pricing platform that BP has built is a differentiator, and it has provided critical business benefits. So this actually platform is an example where BP has developed a large-scale program using cloud-native technologies ground up, and they have built it on AWS. Later on, we are also going to see how this pricing platform uses two other platforms that BP has developed for data analytics and AI/ML. So what we see here on the screen is the pricing execution piece. The pricing program is a 24/7 global application, and it needs to be able to handle variable load. It has multiple components in it. It has a React app front end, it has a back end that manages all the business processes, and it has a database tier. So let's take a look at the architecture from the front end. So we have CloudFront, and that is used for the content distribution piece. We have the AWS Web Application Firewall, and that is used to protect the infrastructure. All the APIs in this application are managed and deployed by Amazon API Gateway. The user interaction with this application all happens via APIs, and in turn, they call several other actions, which are all microservices, and they are built in Lambda. This is a very decoupled application, so you will not have one microservice calling another microservice directly, and all the communication happens via SQS and SNS. The price change workflow takes place using AWS step functions, where it is able to invoke multiple APIs via Lambda functions, and it interacts with external systems like government bodies, regulatory agencies, pricing websites, weather, traffic patterns, and such. Then this application also interacts with internal systems like SAP and several other reporting tools. With each price change, there are several thousand data events that this application needs to react to. A price change is triggered every few minutes in multiple regions, so we know this is a very busy application. Plus, since this application is a very modular, decoupled application, this application is also able to handle complex rule set requirements and help adhere to localizations and help support local laws while putting the pricing strategies together. Okay. So since this is a busy application, there are several reporting applications that are also interested in the data, and a price change has to be reported pretty instantly. We have introduced Amazon Elastic Cache as the caching layer in this application to keep the load off of the database. Now for the database layer, we are using the Amazon Postgres cluster with reader nodes in multiple availability zones. reporting solutions, including the data lake that we're going to talk about here just in a second, or connect to the reader node. Plus, since this application is built using AWS serverless services and it's a busy application, we also have monitoring set up on the service limits in order to make sure that it is not reaching or breaching any default service limits. And in case it's reaching, then we have an alert sent out, and we are able to also put in a request for limit increase where applicable. Now, since this was a very critical application, we engaged in several rounds of performance testing before the go live in every major region. We conducted well-architected framework reviews because those always help uncover some issues that we may have overlooked or missed. We have implemented the AWS Resiliency Hub to make sure that we are able to meet the RTO and RPO requirements set by the business as a part of the DR strategy. We also engaged with the AWS TAM organization and introduced AWS Countdown, which is a comprehensive solution that a lot of our customers use before going live with a major application. And a part of this countdown, customers get assistance in building monitoring dashboards. So overall, there was one differentiator that was called out by the business about this application, and that was the stability of this application and its ability to dynamically handle scale. And we were able to achieve this by using AWS native architecture, best practices, and governance. Okay, so that was the pricing execution piece. Now next, let's take a look at the advanced analytics part. The advanced analytics part for the pricing program is built on the BP AWS Data Hub platform, which is built using the AWS Data Lake concept and is built using the serverless data lake framework. Now, this data hub serves as a central repository for data from different business domains, where users from these business domains create data models for their data analytical use cases like data warehouse, data marts, use case specific data sets. We have data inserted from different applications and systems into this data hub using batch or near real time. And in this case, we are using AWS Glue, Amazon DMS, APIs, and Amazon AppFlow to do the ingestion. Then to apply transformations to this data, we are using AWS Glue, Amazon EMR Serverless, and AWS Lambda functions as the data passes through the different zones, so raw, conformed, transformed, enriched. Okay, so once the data is available in this enriched zone, we are also able to do ad hoc querying on this data, and we are using Amazon Redshift Spectrum, Amazon Athena, BI solutions, as well as the data science platform uses this data hub to build its machine learning use cases. This data hub also supports exploratory data analysis by introducing Glue Data Brew. So now we have business analysts. They also have access to the most granular and raw data available via this platform with Glue Data Brew. This data hub also supports a data mesh architecture where business users are able to create new data products for other teams to consume. Now, in our case, data is ingested from the reader node several times a day. Analysts join this data or enrich this data with other contextual information, and we have pricing analysts build pricing strategies and reports using this data hub. So recently, this data hub also started supporting the Apache Iceberg table format, making this into a transactional data lake, which is now also suitable for operational use cases. Okay, so the pricing platform also uses AI/ML to get insights on how well the pricing strategies are performing, to gain machine learning recommendations on some prices that the analysts can consider. The AI/ML is built using the BP MLOps platform, which is built on AWS using Amazon SageMaker. MLOps is a workload orchestrator where you can get architecture best practice guidance for model productionization. This allows also to have build the entire model lifecycle, right from data preparation, model training, tuning, model deployment, monitoring, and then eventually running inference on the model endpoints. And now, with the advent of GenAI, this platform is further expanding and adding LLM ops, which is large language model operations. And speaking of GenAI and LLMs, this application, the pricing program, also has a generative AI-based pricing analyst assistant. All right, so what we are looking at here on the screen is the architecture for the generative AI-based pricing analyst assistant. Now, pricing analysts are all very data-driven individuals. So they have to analyze data from different markets. They have to build pricing strategies. They also have to take into consideration historical data. Plus, they have to be familiar with regional laws. So keeping all of this in mind, BP decided to introduce a generative AI-based pricing analyst assistant that the pricing analysts can use for training. So let's say they have a question about a BP-defined pricing strategy. They can chat with the analyst. They can also get information about the regulatory laws for a specific reason while building new pricing strategies. The pricing assistant can also alert or trigger a recommendation for the pricing analyst to implement a price change in case there is a change in some of the external systems that usually the pricing analyst watches for. Plus, the pricing analyst can proactively also ask the assistant for pricing recommendations for a region to consider. Okay, so now let's go through the architecture. So this is still part of the pricing execution piece that we saw earlier. So the user interaction is all still happening via APIs fronted by API gateway, and they are built using Lambdas. So when a Lambda gets a request, it passes it to the appropriate processing mechanism. Now, if the request is to get more information about the pricing strategies, then it goes to knowledge bases for Amazon Bedrock, which is represented by Amazon Bedrock on the screen. And it uses Amazon OpenSearch serverless vector databases to store the embeddings. However, if the request is to get new pricing recommendations, then the Bedrock Flows route is taken. So Flows has orchestration capabilities where it is able to build a workflow by connecting several AWS services, prompts, and foundation models. Now, it also supports a visual builder. Flows has a visual builder that one can use to build end-to-end GenAI solutions. So what we see at the bottom of the screen are the different data stores or the data sources that Flows interacts with. So it interacts with those data sources, develops a prompt to analyze those data sources. So with Flows, one is able to actually model the process that a pricing analyst might take when they are analyzing this data and generating a pricing recommendation. All right, and now with that, I pass it back to Tara to go over some of the benefits.
So very much in keeping with the theme of all of the things that we've moved into AWS, we're seeing faster performance. We've brought a lot of efficiency to our pricing analysts. We've consolidated a bunch of disparate apps and made a unified process. And so we're continuing to roll this out, but it's been transformative and quite game-changing for BP. So, you've probably picked up through the course of the conversation that our journey with AWS has actually been revolutionary, I would say, at BP. We are now getting to the point where we are building cloud-native applications. It's enabled better resiliency, faster speed, lower costs for us, and then quite frankly, we're just building better solutions with the AWS tool set. So Amrita actually sits with us on our floor, so thank you to you for going through all of that and for everything that you've helped us with along the way. And thank you for the opportunity to speak to you guys here today. Thank you.
All right, so All right, thank you. Well, so before we wrap up, maybe just a quick couple of things. So there are some QR codes with some resources in case y'all want to just access those. So one is a chalk talk that we did with BP last year, and this was based the ML-based price capture to extract information from trader broker chat messages. We also did this session earlier this year at Energy Symposium, and then wanted to highlight Bedrock Flows because that definitely was a game changer when we were putting the generative AI-based pricing assistant together. And with that, I wanted to thank you all for joining us this morning for the session. And I would like to especially thank Tara for her time and for sharing the BP story with us. All right, thank you. Please do take the session survey. I know y'all are all rushing to the next session, but please do take a few minutes to take the session survey. Awesome. Thank you.